All right, now I want us to work through some mathematical models, so some real-world applications that use square roots. So the first one of these is the Pythagorean Theorem, and it states that when you're given a right triangle, friendly reminder, a right triangle has a 90-degree angle. The Pythagorean Theorem states that for sides A, B, and C, the following statement holds true. A squared plus B squared equals C squared, where C is the hypotenuse, spelling, sorry about that, guys, but that's typically the long side, right? Or the side opposite the 90-degree angle. So I'm going to use what I know about square roots to solve for C in this beautiful triangle below. So I'm going to let 4 equal A, 6 equal B, and my C is unknown. So I'm going to take A squared plus B squared equals C squared. 4 squared plus 6 squared equals C squared. See, I'm just substituting in. 4 squared is 16. 6 squared is 36. That leaves me with C squared is 16 plus 36, which is 52. Now I'm going to take the square root of both sides. So I get the square root of 52 equals C. Now 52 is not a really nice number, okay? 52 factors into a 4 and a 9, 3 and a 3, 2 and a 2, okay? Does it factor into a 4 and a 9? Factors into a 2 and a 27. Let me try that again. 2 times 27 is 54. There, that looks better. Okay, so this isn't going to have a really nice square root because 54 is 2 times 3 cubed. So we can just leave it as the square root of 52. Next, I can also use the distance formula. This is not something you need to memorize, okay? This will be given to you. So before we've had the midpoint formula, which found the point in the middle of a line, right? Now I have the distance formula. This will tell me how far away 2 points are, okay, using the square root property. So for the distance formula, I take x squared minus x sub 2 minus x1 squared plus y2 minus y1 squared, okay? So as long as you're given any 2 points on the coordinate plane, you can find the distance between them. So let's say I have x1, y1, and x2, y2. You're just going to go ahead and substitute in. So I'm going to take 3 minus a negative 6 squared plus negative 4 minus 5 squared, okay? The distance is now the square root of 9 squared, because 3 minus the negative 6 is a positive 9, plus negative 9 squared. So my distance is the square root of 81 plus 81, which is the square root of 162. Next thing I want to talk about is equations for a circle. So an equation for a circle with a radius r and center hk is given by x minus h y squared plus y minus k squared equals r squared, okay, where r is our radius. So if I want to find the equation of a circle with the radius square root of 7 and the center x is negative 1, y is 2, I'm going to have x minus negative 1, right? My center hk, even though it's a minus k, I write it of this form, so minus 1 squared plus y minus 2 squared equals the square root of 7, that's my r, squared. So I'm left with x plus 1 squared plus y minus 2 squared equals The square root of 7 squared, which is just 7. So let's take a look at these circles. I want to find the center and I want to find the radius. Okay, so if I have x minus h squared plus y minus k squared equals r squared, hk is my center and my radius is r. So let's take a look at this first example right here. What is my h? Am I adding anything to my x? No, so h is 0. What's my k? Am I adding anything to y? No, k equals 0. I also know that 16 equals r squared. The square root of 16 is 4. So this circle has a center of 0, 0, and a radius of 4. All right, let's take a look at this next example. I have x minus 1 squared plus y minus 2 squared. My h is, because it has to look like x minus h, which it already does, so my h is 1. My k, it has to look like y minus k, and it does, so I have k is 2. And my square root is, and my radius, r squared, is 16. Well, the square root of 16 is 4, so r is 4. So this has a center of 1, 2, and a radius equal to 4. Okay, let's try again. I have x minus 3 squared plus y plus 4 squared equals 9. Remembering, I have to have x minus h squared plus y minus k squared equals r squared. I have to have these written with a negative. So let's rewrite this. I have x minus 3 squared plus y minus negative 4 squared equals 9. My h is 3. My k is negative 4. If my r squared equals 9, then r is 3. So I have center 3 comma negative 4 and radius of 3. Last but not least, I have x plus 2 squared plus y plus 2 squared equals 9. I need to rewrite this so I have negatives. This gives me x minus negative 2 squared plus y minus negative 2 squared equals 9. My h is negative 2. My k is negative 2. My r squared is 9, so my radius is 3. So I have a center of negative 2, and a radius of 3. Now I want to talk about solving radical expressions. Okay, solving radical expressions that contain square roots. Okay, the first thing you're going to want to do is you're going to want to isolate the radical. Then you're going to square both sides of the equation to eliminate the square root, solve the resulting equation, and check any values that remain. So let's go ahead and work through some examples. If I have the square root of 3x plus 4 equals 8, this is our first example right here, I'm going to square both sides to eliminate the square root. Remember, what I do to one side, I need to do to the other. Square roots cancel squares, so I'm left with 3x plus 4 equals 64. I divide both sides. Nope, I subtract 4 from both sides to get x all by itself. So I have 3x equals 60. I divide both sides by 3. I get x equals 20. So I'm going to plug that back in. to check my answer. The square root of 3 times 20 plus 4 equals 8. That gives me the square root of 64 equals 8, which is true. So x equals 20 is a solution. Okay, let's take a look at this example number 2. If I have the square root of 5x minus 1 plus 3 equals 0, the first thing I need to do is isolate the variable. Isolate the radical. So I'm going to subtract 3 from both sides. That leaves me with the square root of 5x minus 1 equals negative 3. I go ahead and square both sides to cancel out the radical. That leaves me with 5x minus 1 equals 9. I add 1 to both sides. 5x equals 10. I divide both sides by 5. So I have x equals 2. Now I need to go ahead and check that in our original equation. Let's check it in a different color. How about green? So if I have the square root of 5 times 2 minus 1 plus 3 equals 0, that leaves me with 5 times 2, which is 10, minus 1 is 9. So I have the square root of 9 plus 3 equals 0. Well, the square root of 9 is 3. 3 plus 3 equals 0. Nope, so there is no solution. No solution. Remember when I'm taking the square root of 9, I always want the positive or the principal square root, okay? Let's clear everything and take a look at example 3. I guess we're green now. So I have the square root of 4 minus x equals x plus 2. Step 1, isolate the radical. Check. Step 2, square both sides of the equation, eliminate the square root. That leaves me with 4 minus x equals x plus 2 squared. That means I need to FOIL this out. So I have 4 minus x equals x squared plus 2x plus 2x plus 4. Now I can combine like terms. And remember, in order to solve what I now have as a quadratic of degree 2 equation, I need to make one of the sides equal to 0. So I have x squared plus 4x plus 4 equals 4 minus x. I'm going to add x to both sides. That leaves me with x squared plus 5x plus 4 equals 4. I subtract 4 from both sides. I get 0 equals x squared plus 5x. Now, how might I go about starting to solve this? I'm going to want to pull out the greatest common factor. That means I have 0 equals x times x plus 5. So now I have 2 possible solutions I could have. X equals 0 and x plus 5 equals 0, which is x equals negative 5. Okay? I need to check these proposed solutions back into the original equation and discard any values that are not actual solutions. So I'm going to write them up here. I have x equals 0 and x equals negative 5. Give us a little more room to work. Okay, friendly reminder, we're still working on problem 3. So I worked through up to step 3 and found that x equals 0 and x equals negative 5. Now I need to check this into our original solution. So let's start with x equals 0. If I have the square root of 4 minus 0 equal to 0 plus 2, I get the square root of 4 equals 2, so 2 equals 2. Awesome. So x equals 0 is a solution. Next, I need to plug in x's negative 5. If I take the square root of 4 minus negative 5 equal to negative 5 plus 2, that gives me negative 3. Square root of 9. 3 does not equal to negative 3, so this is not a solution. Last but not least, let's go ahead and take a look at problem number 4. Problem number 5, I'm going to lay it for you guys to work through the example in the book on your own. So, first thing I want to do again, isolate the radical. If I have the square root of x squared minus 4x plus 9 equals x minus 1, I square both sides, remembering that because I have a binomial over here, I'm going to have to FOIL. So I'm left with x squared minus 4x plus 9 equals x minus 1 times x minus 1. That's going to give me x squared minus 2x plus 1 is x squared minus 4x plus 9. So let's go ahead and solve this. I'm going to subtract x squared from both sides. That gives me negative 4x plus 9 equals negative 2x plus 1. I'm going to add 2x to both sides. So I have negative 2x equals plus 9 equals 1. I subtract 9 from both sides. Negative 2x equals negative 8. So x equals 4. I'm going to leave it to you to check your solution into the original equation.